Hello students, I hope all will be good. So let us start with a chemistry lecture. Students, with our topic alcohol, phenol and ether, let us start with today's subtopic, that is ether. Preparation of ether. Now let us start with the subtopic ether, and in ether we will start with preparation of ether. Now the first is dehydration of alcohol. Alcohol when heated with dehydrating agent like concentrated sulfuric acid or phosphoric acid, two products are formed depending on temperature. Here students, temperature, it plays a very important role. In this reaction, either an ether or an alkene will be formed. Now students, this reaction takes place at a specific temperature, and dehydration of ethanol takes place with sulfuric acid. Ethoxyethane is formed at 413 Kelvin and ethene is formed at 443 Kelvin. So here students, as we see that temperature plays a very important role. Ethanol, it is formed at 413 Kelvin temperature, and ethylene will be formed, that will be at 443 Kelvin. So ethanol gives ethoxyethane depending on the temperature, that is 413 Kelvin, and ethanol gives ethylene, that is at temperature of 443 Kelvin. Now here students, the dehydrating agent used is concentrated sulfuric acid or phosphoric acid. Now alcohol at 443 Kelvin, it gives ethene. Same way, alcohol at 413 Kelvin temperature, it gives ether. Now condition for formation of ether, that is, it has to be very low, the temperature has to be low. Alcohol has to be less steric hindrance, that is less crowded. And students, this follows as an SN2 mechanism. So this reaction, it follows an SN2 mechanism. Now very important topic, that is Williamson synthesis. Students, here simple as well as mixed ether can be prepared by Williamson synthesis. When an alkyl halide is treated with sodium alkoxide or sodium phenoxide, that is with alcoholic sodium or potassium alkoxide, it gives corresponding ether. Now students, in Williamson's synthesis, alkyl halide is treated with sodium alkoxide or with sodium phenoxide to give dialkyl ether or diaryl or aryl alkyl ether. So students, here when alkyl halide is treated with sodium alkoxide or sodium phenoxide, it gives dialkyl ether or alkyl aryl ether. Now this reaction also follows SN2 mechanism. Now students, here you will see that alkyl halide when treated with sodium alkoxide, it gives diethyl ether. This is a simple ether. an alkyl halide with sodium phenoxide, it gives alkyl aryl ether, that is mixed ether. Now this reaction which is there, alkoxide with primary alkyl halide gives unsymmetrical, that is mixed ether. Now students, you must have studied about simple or symmetrical ether or mixed, that is unsymmetrical ether. Now when same group are present at both the end of oxygen, then it is called as simple ether or symmetrical ether. And if different groups are present at both the ends of oxygen, then it is called as unsymmetrical or mixed ether. One thing more important, here the alkyl halide used, that is methyl bromide, is primary alkyl halide and less hindered or crowded. Now students, Williamson synthesis helps in preparation of unsymmetrical ether in primary alkyl halide. This is very important, that in Williamson synthesis with primary alkyl halide, it helps in preparation of unsymmetrical ether. Now the next one is secondary and tertiary alkyl halide in Williamson's synthesis. Now students, over here, tertiary butyl chloride, when it is treated with sodium ethoxide, you get isobutene and ethanol. Now here students, if secondary or tertiary alkyl halide are used in Williamson's synthesis, it gives an alkene. Now this is so because secondary and tertiary alkyl halide which is used, it is more crowded or more steric hindered. Now very important thing, that aryl halide do not give Williamson's synthesis. Now ether, we'll see about the physical properties of ether. So now we'll see about the physical properties. Physical state and boiling point. Dimethyl ether and ethyl methyl ether are gases. Other ethers are colorless liquid with present order. Next, lower ethers are highly volatile. Volatile means they will directly get converted into gaseous state, and highly inflammable substance. Next, boiling point of ether shows gradual increase with increase in the molecular mass. So as the molecular mass goes on increasing, the boiling point of ether also gradually increases. Now students, here we can see that in this table we can see the boiling point of some of the ethers are given over here. So you can see that the boiling point goes on increasing over here. The boiling point increases with the increase in the molecular mass. Now the next is polarity and solubility. Now the group which is present over here, COC, this group which is there, this is called as an ether group. It is an ether. Now in this, the net dipole movement which is there, the net dipole movement, we can see over here. Now the bond angle of ether is 110 and it is not 180 degree. So the bond angle is 110 degree but not 180 So this is a small net dipole movement. So because of the change in the angle, so it is 110 degree. So you will find a net dipole movement is present over here. So the bond dipole movement of the two CO bond do not cancel each other. Now here we will see the molecular mass and the boiling point. And heptane, it has a molecular mass of 100. Methyl and pentyl ether, molecular mass is 102. And hexyl alcohol, it has molecular mass of 102. Now boiling point of N-heptane is 371. Methyl and pentyl ether, boiling point is 373 Kelvin. And for N-hexyl alcohol, the boiling point is 430 Kelvin. Now here we can see weak polarity of ether does not affect the boiling point of ether, and this boiling point are same as that of the alkenes. So the boiling point of ether is same as that of the alkene. Now here we can see the hydrogen bond of ether with water. Intermolecular hydrogen bonding that holds alcohol molecule together is not present in ether and alkenes. Students, over here both alcohol and ether show similar solubility and miscibility. Diethyl ether and N-butyl alcohol have same miscibility with water, that is 7.5. So if we will see the miscibility with water, then we can say that diethyl ether and N-butyl alcohol have the same miscibility, and that is about 7.5. Now the next topic we'll see is about chemical properties of ether. Now the first one, laboratory test for ether. Ether in aqueous medium are neutral. Ethers do not react with base, cold dilute acid, reducing agent, oxidizing agent and active metals. So they do not react with all this. But ether dissolves in cold concentrated sulfuric acid, and you will get the formation of oxonium salt. So this is very important, as this property helps in distinguishing ether from hydrocarbons due to the formation of oxonium salt. Involving alkyl group of ether. Formation of peroxide. Here you can see the molecule of diethyl ether. It reacts with oxygen and gives peroxide of diethyl ether. Ether combines with atmospheric oxygen to form peroxide. Students, over here, with atmospheric oxygen, ether forms peroxide, and this peroxide form is hazardous because they become volatile at high temperature. So over here this peroxide which is formed, it is highly hazardous. Now reaction involving CO bond. Reaction with hot dilute sulfuric acid. This reaction is also called as hydrolysis reaction. Ether, when heated with dilute sulfuric acid, undergoes hydrolysis to give alcohol or phenol. So here students will see that when ether it is treated with dilute sulfuric acid, you get alcohol over here, and also you get the formation of phenol. Now reaction with PCl5. Now ether reacts with phosphorus pentachloride to give alkyl chloride. Now reaction with hot concentrated acid, ether, it gives with alkyl halide. Ether when reacts with alkyl halide, it gives an alkyl halide and alcohol. Alkyl ethers react with concentrated HI, that is hydrogen iodide. Alkyl ether reacts with concentrated HI and HBr to give alcohol and an alkyl halide. Now the order of reactivity of HX is HI, it is more reactive, HBr, and then HCl. So HI, it is more reactive, hydrogen iodide, HI, it is more reactive, then hydrogen bromide, and then HCl, that is hydrogen chloride or hydrochloric acid. Now students, anisole with HI at 398 Kelvin, it gives phenol and methyl iodide. Hydrogen iodide reacts with alkyl ether to form a phenol and an alkyl halide. Now students, anisole which is there over here, this is also called as methoxybenzene. The bond between oxygen and aromatic ring is stronger and shorter, so there is a cleavage of oxygen and alkyl bond to give a phenol and an alkyl halide. Now the next is electrophilic substitution in aromatic ether. In aromatic ether, the alkoxy group is ring activating and ortho para directing group towards electrophilic aromatic substitution. Here students, we can see the resonating structure. Now here the plus R effect of OR group results in increasing the electron density at para and ortho position. Now the next topic is halogenation. Anisole, that is methoxybenzene, undergoes bromination with bromine in acetic acid. Now here students, the reaction takes place even in the absence of FeBr3, that is ferric bromide, which act as a catalyst due to activation of benzene ring by methoxy group. Para forms a major product and ortho forms a minor product. So over here the bromine which is present, it is at para position, it forms a major product, and if bromine is at ortho position, it will form a minor product. Now most important reaction in ether we'll study now, that is Federal-Kraft reaction. Now anisole, it reacts with CH3Cl in presence of Lewis acid, that is AlCl3, which act as a catalyst to give 4-methoxytoluene, that is the major product, and 2-methoxytoluene, that will be the minor product. In same way, anisole, it reacts with CH3COCl, that is ethanoyl chloride, in presence of Lewis acid, that is AlCl3, to give 4-methoxyacetophenone, that will be the major product, and 2-methoxyacetophenone, that will be the minor product which will be formed. Now our next reaction is nitration. Anisole reacts with concentrated nitric acid in presence of concentrated sulfuric acid, which is also called as nitrating mixture, to give a mixture of ortho nitroanisole and para nitroanisole. See in the reaction over here, anisole in presence of nitrating mixture, that is concentrated HNO3 and concentrated sulfuric acid, it gives 4-nitroanisole, that is the major product, and 2-nitroanisole, that is the minor product. Here students, concentrated nitric acid, that is HNO3, is an acid but it acts as a base over here, and concentrated sulfuric acid acts as an acid. Now in this reaction, NO2 is generated. This NO2, which is nitronium ion, generated act as an electrophile. Now anisole with this concentrated nitric acid and concentrated sulfuric acid, it gives para-nitroanisole and ortho-nitroanisole. Now the next is uses of alcohol, phenols and ether. Uses of alcohols. Methyl alcohol is used as a solvent for paints and vanishes. Ethyl alcohol is used as antifreeze agent in automobile radiators. It is also used as solvent. Uses of phenols. Phenol is used in preparation of phenol formaldehyde resin, for example brachylite. Phenols are used as antiseptic in common products like air fresheners, deodorant, mouthwash, calamine lotion, floor cleaners, etc. Uses of ethers. Earlier, diethyl ether was used as a general anesthetic in surgical operations. Diethyl ether is used as a solvent for Grignard reagent for fats, waxes, oils, etc. So these are the uses of alcohol, phenols and ethers. Thank you, students. So here we come to an end of the topic alcohol, phenol and ether.